layer, we have seen some general descriptions of the network layer. What does it do? Why do we need it? We have seen also congestion control in the presentation earlier. So now we continue with the network layer called network layer in the internet. And just some design principles. If we are designing this particular layer, a few things that we need to keep in mind. The first one is make sure it works. This means we need to develop multiple protocols and try them, multiple prototypes and try them until we are sure that one of these prototypes is successful. Keep it simple. We have seen this programming rule before. Keep it simple, silly, which is try to use the simplest solution and don't make the design too complex. Make clear choices. If there are several ways to do the same thing, we should choose one of them to avoid ambiguity. Modularity. This has to do with the layering design. So the entire network is designed as a stack of layers, and here we use the same rule. Modularity means break the design into smaller manageable pieces or stack of layers. The next one is heterogeneity. Expect that, which means expect networks of different types with different configurations and parameters on the way. So this network layer, at the network layer, we need to deal with this and make our packet go through all the networks in between the sender and the receiver, dynamically adjusting to the various properties that we might encounter. So we are expecting that, or we are being prepared for that. Static options and parameters. Avoid static options and parameters. By this we mean to have the sender and the receiver negotiate what options and parameters they're going to use before they start the communication, instead of imposing on them statically configured parameters. So we are avoiding fixed values. Good design, not perfect. This means if we have a pretty good design that functions for the most part, 99% of the time, we're not going to change or break that design because of this 1% case that is having issues with it. So we will allow them to deal with their issues. In other words, let them handle their own issues and program whatever parts they need to change for themselves. Strict sending, tolerant receiving. This means we always follow the rules when we generate packets, but we expect that the packets we receive may not be following the rules. And scalability. This means we should avoid centralized databases because they don't scale well, but for example distribute them in multiple locations. And finally, when we're designing protocols in this layer, we need to think about the cost, how much they would cost, and the performance. So no poor performance, and avoid poor performance and avoid very high costs. This is what we have seen in the presentation earlier as well. So at the network layer, the internet can be viewed as a collection of networks or autonomous systems. So the internet itself is a network of networks. So it connects together many other networks. Like for example, this here is a regional network considered an autonomous system, which means it's a separate system that is connected to another network, let's say this backbone. Then this WiMAX is another autonomous system connected to the rest of the networks. Let me write this down. Network layer at the internet. So in the network layer, internet can be viewed as a collection of networks also called autonomous systems. Which are interconnected. In that picture, we have several backbones that exist. These are the backbones. They are constructed of high bandwidth fiber optic lines that go across continents. These are called the Tier 1 lines. Several backbones exist, constructed of high bandwidth lines. And fast routers. The biggest one of these is called Tier 1 network. Attached to the backbones are the internet service providers, which provide service to regional networks and local networks. So we have backbones. Next we have Internet service providers, which provide access to the rest of the networks, to homes and businesses, as well as data centers, and regional networks. Regional networks, and attached to these regional networks are the home networks. Structure. We have backbones, tier 1 networks, internet service providers attached to them, homes, businesses, data centers, and regional networks attached to the internet service providers, and to the regional networks are attached the home networks. This is the structure of the internet. It doesn't really have any structure because it's a network of networks that connects these separate autonomous systems together, and that is what it looks like. So the glue that holds this system together is the Internet protocol. So the glue that holds the Internet together is the network layer protocol called the Internet Protocol. Or IP. We have already seen that the job of this layer is to provide a best effort support to transport packets from source to destination, no matter how many hops and networks are in between the sender and the receiver. So best effort, which means not guaranteed. To transport packets from source to destination. No matter how many networks or hops are in between. The data streams come down from the transport layer and they get to the network layer. The network layer job is to provide service to the transport layer, which is right above it. That's what is the job for every layer, to provide service to the layer above. So the data streams come from the transport layer down to the network layer. So the transport layer breaks these streams into pieces. Each piece we'll call a packet. The size of this packet can be up to 64 kilobytes. That's allowed. In reality, most packets are 1500 bytes. The routers forward the packets until they reach their destination, and when they reach the destination, the pieces are assembled back together. So the original message or stream is broken down into pieces called packets. These are transported by routers until they reach the destination. And at the end, they are assembled back into the original stream by the receiving machine. message becomes a packet. So let's see how this internet protocol works.